My name is Agita, and today I will talk a bit about DevOps best practices and how they influenced DataOps Mesh or DataOps and data mesh concepts. I will provide an overview of each of these paradigms and explore how realistic it is to combine them. So it's very beginner friendly, and if you are data or DevOps engineer and you're curious about data best practices or data ops, this talk is for you, as well as if you are a data engineer and you are curious about DevOps best practices, this is also can be useful for you. A little bit about me. At the moment, I work at VMware. I'm part of Versatile Data Kit team. It's an open source project that is automating actually data ops processes. So that's why I'm curious to talk about it. I'm going to touch a little bit on promo Versatile Data Kit because I'm on a mission to create a community around this project at the moment. And I believe it's relevant to the topic and solve some problems that I will address. My personal connection to and interest to the topic is that at the moment I'm a community manager, but I have actually DevOps background. I worked as a DevOps engineer for around 5 years before transitioning to community management with 3 years burnout period when I didn't work. So I have some context and personal interest in talking about these concepts. And as a DevOps or ex-DevOps engineer, I'm actually very excited to learn and use my experience to envision how data engineering teams can use their full potential following DevOps best practices. Learning about DataOps and data mesh as part of this project that I'm working on now made me excited about this combination, and actually I'm a bit of efficiency freak, and I believe this can be is a very efficient combination. At the same time, I believe that there are some challenges that might arise, and I'm going to also address these challenges. And just a final thing is that I want to say also kind of thanks to open source in general, existence of open source projects, because kind of after a little bit I mentioned the burnout. After the burnout, I realized that I want to make this world a little bit a better place. And for me, working or coming back to DataOps or DevOps world was only possible if I work on some open source project. Also, you will see some graphics that I made actually, in these slides, you will see some graphics that I made, and I just discovered that I have this little pen, and I have a touch screen. My screen is working with this pen, and so I created several graphics here. They are not professional at all. This is my first time drawing, but I just did it for my own pleasure and fun. So let's start. So my agenda for today is I will start with an introduction to DevOps best practices. And then I will explain DataOps and how they're kind of correlated. Then I will go into Versatile Data Kit introduction very, very briefly, because I'm going to explain DataOps lifecycle in the context of, or kind of with the example of the tool or framework. Then I will explain what is a data mesh, and then I'm going to combine everything that I just talked about into this DataOps mesh concept that, well, basically I came up with by myself, but I imagine that, and actually I have seen that some people also are talking or writing about this combination, powerful combination, in my opinion. And then I asked, or kind of the problems that I believe that might be there for the people who are trying to implement both of these or combine these two concepts, and also some solutions that I came up with on this research of creating this talk. Then I will talk a little bit about open source projects and just invite you to offer a little contribution. So, for me, DevOps best practices basically are mainly focused, let's say, or I want to highlight two things. And first is automation, and second is collaboration. Both of these I experienced I think on personally working in 2 projects, and my experience in DevOps was first I joined a smaller project of 7 people, and I worked there for 3 months. And the second project was quite large. I think there were several thousand people in that project then when I joined as a DevOps. And I stayed in that project for 4 years. And to explain what I was doing there, maybe first project is more emphasized. I will kind of speak about it in context of automation, and the second one in the context of collaboration. So when I joined the first project, basically what happened on my first day, I arrived as a junior DevOps engineer, and they gave me just maybe 7 to 10 pages of A4 printed paper with instructions that I have to follow every day. Basically, my task was to support the migration of older Spring version to a newer Spring version of the code or of the tool that developers were working on. And in order to do this, to support this migration, I had to change several lines in some files, copy some folders, rename some things, do testing on Linux, do testing on Windows, and deployment tasks that were done completely manually before I joined. And so what happened actually in my first week, I managed to once go through the list of these instructions. And by the end of the day, really, I'm super happy. I'm turning to my lead and I'm saying, hey, hooray, I finished this. So I went through the instructions, so it's done. And my lead turns back to me and he says, today actually we have to do this or repeat this 4 times more. And it was approximately actually 6 p.m. So it was the end of the working day. And I decided to prove myself and stay at work and follow the instructions and do it 4 more times. I think it took me 4 hours to do it the second, third, and 4th time. And it got me frustrated enough, so to say, to promise myself that I will not repeat this. And so the next day when I arrived to the office, I just decided to start writing code. I started writing code with, the simpler things like copying files, renaming some folders, and then kept going and automating them more into changing the lines in the code. And basically, the idea is that by the end of those 3 months when I was in this project, I have automated absolutely everything. So I wrote code to automate every step of this process that was written across these pieces of paper. And basically I learned, and to me it was quite obvious that if something can be written on paper, it can be definitely automated. And the team was actually really surprised, and I think for them it wasn't that obvious, but they were actually super happy to see how I automated this whole process. That by the end of those 3 months, this deployments could be done completely automatically. I think around 280 times in 2 hours or something. So literally, I had nothing to do there, and even though the team wanted to keep me around, there was just no tasks to give me. So this is how I believe that DevOps is supporting automation, and also it goes a little bit in the second point in my slides, which is faster, better, cheaper. So no human error is there, everything is happening way faster than any manual work, and of course it's cheaper to have automation doing things instead of people. I was using CI/CD tools and writing jobs on Jenkins at the time, and making pipelines that are automating the process, and basically following the DevOps lifecycle and orchestration. What was not part of my job actually in this project. So I go into the next project. when I finished with this 3 months in the first project, I got invited to another project that was basically infrastructure automation or orchestration with Chef. But what I want to actually, and what struck me the most in that project was that it was really focused on collaboration. So at the time I was living in Latvia, and the project was on site, so it was in Germany. So every Monday, every week I was traveling to Germany, and every Thursday I was traveling back. And at first it didn't make any sense, but with time and actually with experience, I understood that it makes a lot of sense to be in the same room with other people who are working on the same thing. As I mentioned, the project was huge. There were like many developers and apps and things getting built. But all the people who were working on it actually were in the same house, like in the same office, or most of them. But even further, the people who were automating things, not just DevOps people, but everyone who was doing any type of automation, actually were in the same room. So I got to meet these people that I'm working with, and actually it was great experience to learn the methodology, the mindset, and this collaboration to grow in this collaborative space where whenever something breaks, we all get together and we are solving the problem instantly on the spot as soon as possible. And it just increases efficiency to the maximum when I know that if I have a problem, I can go to this particular person, or I can ask someone who knows someone else who might contact me directly with the person, and then we talk face to face. And of course, it was pre-COVID or before COVID times. And now the world is a little bit different, but I still believe that it is possible to have the same level of collaboration between people if the teams are really connected. And this is going to be really relevant when I talk about data mesh, because splitting teams or putting all the relevant people in the same room or the same team, even virtually, will make the big difference. So, DataOps best practices. Basically, in a nutshell, DataOps is DevOps or data engineering equivalent of DevOps best practices. The idea is to speed up the data deployments while improving the quality. DataOps lifecycle is similar to the DevOps lifecycle. I'm going to dig deeper into it in the next slide. Here I wish to mention that DataOps lifecycle actually hasn't been really agreed upon in the community. There are several options and several ways to see it, and I'm going to present my personal, let's say, subjective view on it after reading or researching on the topic. The difference between traditional data engineering and DataOps is that DataOps engineers work with data in an automated way, building their workflows or data pipelines and jobs that run automatically. So basically, these data pipelines and jobs are kind of similar language or taken also from DevOps world. So if previously one data team might be dependent on another data team, or on infrastructure team because of the sequence of data journey or some infrastructure permissions or accesses, now is kind of solved. So DataOps is solving this, let's say, decreasing dependencies, but I would not say that it's completely eliminating the dependencies. I believe also that the people who are building data pipelines should be enabled to set up the infrastructure and orchestrate the entire data journey. So in perfect case scenario, data pipelines and infrastructure are built and maintained by the same people, which is not always the case, but still I kind of want to focus or have this in mind when I'm talking about DataOps. Still, data teams are sometimes separated, but let's say I believe that it shouldn't be the case, and as I talk about DataOps, I take in consideration that they are doing the same thing together. So orchestration and building the pipelines. So as I'm going to jump into DataOps lifecycle and kind of give a practical example of it with Versatile Data Kit tool, I just wanted to highlight or explain a little bit what it does. So Versatile Data Kit is an open source project, as I mentioned, and it is found on GitHub. The code is there. And basically what it is, it's a framework that is created to build, run, and manage data pipelines with basic Python or SQL knowledge with on any cloud. So the emphasis kind of that is maybe relevant, and I believe relevant for this talk, is that we use the word basic. And it's going to solve a little bit later one of the problems that I'm going to address. So basically, I'm going to explain also what is a data pipeline. A data pipeline is a series of data processing steps scheduled and executed in a sequence, the same as in case of DevOps. But this pipeline exists in order to ingest, load, and transform the data from its source to where data analysts can work with it. In some cases, the steps are also in sequence. In some cases, independent steps might run in parallel as well. Yeah, and now I will go to DataOps lifecycle to kind of explain also how it comes all together. Yeah, so basically this is the DevOps lifecycle as I see it. Plan, code, orchestrate, test, deploy, execute, monitor, and feedback. And it goes, and it cycles. It is similar to DevOps lifecycle in my opinion, but a little bit different. So I'm going to go through each step, and then you can see the difference for yourself. So of course, the most important, I believe, part of the lifecycle is to plan. As we know, failing to plan is planning to fail. So this is the crucial step where the business value, users, and requirements are gathered, and the tools are selected, and everything that needs to be answered here. So if the plan is solid, we can proceed to the second step. The second step is code. Coding in Data Vault means writing the code for a pipeline to ingest, transform the data, and test it locally. In our case, Versatile Data Kit automates this part by introducing software development kit. The code can be written in Python or SQL interchangeably, as I mentioned, and is used to create data jobs with steps that run in specified sequence. Also, database is selected and configured, and the data jobs are executed locally to test the code and make sure that data is ingested and transformed properly. So simple command like vdk run is going to run the whole pipeline locally and give me the output, and I can check if the desirable outcome is there. There are many other tools that automate this step. Actually, it may be using also other languages, or even taking coding part out of the equation and providing an interface where data practitioners can do this by clicking buttons. For some, it might be very helpful, and for some, it might be frustrating that we cannot debug as easily things. So the third step is orchestrate. This is a crucial operations part of the cycle. This step actually is independent from, let's say, code, but definitely needs to be implemented or brought in before testing part. It can be also the case that the infrastructure team is setting up orchestration and the data team is doing the coding part. But as I said previously, it's better when it's done by the same team. To have a full ownership over the pipelines. The infrastructure is built here for the data to go through the environments like staging, where it gets tested and further promoted to production environment or pre-prod and used for analysis. Typically, the code is pushed to Git, and then data is ingested into staging before it gets deployed to production. At this point, the scheduling and orchestration of the pipeline is configured in the configuration files in case of VDK. Orchestration tools can schedule jobs, manage workflows, and coordinate dependencies among tasks. VDK has implemented a control service component that is taking care of the infrastructure setup. So it is kind of also taking part in automating with this SDK the code stage and the orchestration as well, introducing this control service that is creating the infrastructure. Then the next step is testing. So the testing, once the data job runs on staging, the data can be tested. Now there are alerts for any user or system errors that can be tracked. End-to-end testing ensures that no existing functionality is impacted. And maybe some things that haven't been considered in the workflow, such as what would happen if, and so on, and any type of bugs or discrepancies are fixed at this stage. Deploy stage is after validating the data and resolving issues, it can be deployed to production. Deployments can be fully automated, so let's say if the data gets to staging and is tested automatically, it can automatically also get deployed to production, or another way also can be introduced. Then execution. Execute step is the pipeline now is running automatically based on the configuration. Automated data lifecycle processing is in place, which scheduled ingestion, transformation, testing, and monitoring. Now reports can be generated. VDK control service has functionality for both deployments and execution of the jobs. Monitoring is in place to track failing as quickly as possible. Usually it's automatically set up to alert the data jobs if the data jobs are failing. Alerts will be sent out to the user specified email and provide containing data job name and type of error. It is also possible with VDK in this case to detect if it's a user side error or a system error or like a configuration error. Or a platform error, which is going to be also included in this alert message. Then monitoring is going to provide this information to help users to troubleshoot and fix their pipelines as soon as they get the alert. The final step is feedback, and here the additional requirements might arise. Some data might be missing, or something might be necessary to improve. So when the feedback is collected, again, the planning can be done and the cycle repeats. So here I sketched a little bit with my little pen. Also some components of VDK that I was mentioning here in this previous slide for the visual representation, just because I understood for myself that I would need something like this in order to understand it better. Some of the components, but not all of them. But basically, so this is, let's say, data part, and this is like ops part that is combined in the Versal DataKit project. So data jobs are running in Python or SQL. There is a command line interface where I can run jobs locally and test them. The data jobs are following these steps. So, and actually it's prefixed by in alphanumerical order. So let's say the name of the file is going to also be the sequence, defining the sequence. It is doing ETL or ELT, actually automation, which is extract, transform, and load by providing plugins and templates. and in general automating these parts with so not really in-depth knowledge is necessary to do them. And so basically it's for locally running these jobs. And then the other like kind of ops component is scheduling and execution of these jobs in Kubernetes environment using Git. So we upload the code to Git and then we deploy it, and from there we can set secrets if necessary and monitor the pipeline. And now I jump into Data Mesh. And Data Mesh was actually is quite a new concept. I would say younger than way younger than DevOps and younger than DataOps as well. But nevertheless, it's extremely popular now. I think people are really considering this as a really good practice. So it was invented by Zhamak Dehghani in 2019, and basically it's a type of data platform architecture that leverages domain-oriented and self-service design to embrace the ubiquity of data enterprises. In this case, the domain is a business area, meaning each business area owns its data. And the data meshes foster data ownership among data owners who are held accountable for delivering their data as products. And so data as product actually kind of comes in. Each domain is responsible for managing its pipelines, and once the data has been served and transformed by a given domain, the domain owners can then leverage the data for their analytics or operational needs. As Zhamak argues, data architectures can be mostly easily scaled by being broken down into smaller domain-oriented components. In short, data mesh means that the data owners or domain owners, people who are directly involved with particular data, are also building and maintaining their data pipelines. Users are becoming the owners, and so the data becomes a product and is self-serviced. This alone also does not completely eliminate dependencies, because let's say if we implement data mesh and the orchestration and testing and CI/CD are set up by another and managed by another team, then the domain owners will depend on the infrastructure engineers who will be supporting the orchestration. So this is the reason why I decided kind of to combine these two paradigms or concepts. So here is the data mesh on the left, like adding governance, self-service, data as a product, and domain ownership to the data and to the data cycle. And DataOps, part of it, that is providing the CI/CD, testing, observability, and orchestration. So yeah, and basically, kind of seeing this image. This is not my original image. I found it in an article, and then I kind of made it into my own graphics. But this is how I also inspired to think about the combination of DataOps and data mesh, which I strongly believe enables true collaboration and powers up the data engineering process by completely eliminating dependencies. So if the DataOps engineer owns the data pipelines and is enabled to have ownership over the infrastructure and orchestration of the data cycle, and data mesh means that the domain owners are owning the data, as well as the pipelines, and in this case, infrastructure too, I believe that the result will bring the speed to the data-driven projects to be as fast as possible with no dependencies. Which I believe is already happening in the DevOps role, because sometimes, let's say, full-stack developers or DevOps engineers can set up the infrastructure, build the pipelines, and or be in the same room with the developers who are directly working with the building the product. So, how VDK supports data mesh? Well, data mesh is an organizational concept. It is implemented by managing the teams and enabling them to work fully with their data. Besides automation of the process, Versatile Data Kit introduces the functionality of creating teams. So basically, as a data job is created, the prerequisite is to also specify which team is going to be working on it. Besides the team functionality, VDK also has templates and plugins to support these teams. And in order not to reinvent the wheel each time, teams can share the work they've done with each other and collaborate more efficiently. And these are some of the functionalities that can support efficient DataOps Mesh implementation. So what can go wrong? Well, I believe that two things can go wrong and or possibly like prevent DataOps Mesh from happening. And the first one is the skills. So kind of while I was researching this, I was thinking that, basically I was thinking that the required skills to execute DataOps combined with data mesh successfully are, so skills or knowledge. The person in the team in each domain should have the knowledge about the domain. Then they have to have data engineering skills like Python or SQL or anything else depending on the tool that they're using for writing their pipelines. And the third thing is that they need to know is how to set up their infrastructure and basically DevOps skills. And so as I was creating these slides, my question was whether it's easy or even possible to find a person who might fit and have all these skills that are necessary for this, or actually if it's possible to train them, or even if they would be willing to learn. But as I presented this talk to my team, this presentation and actually this topic in general, it became obvious that the skills issue actually is solved by VDK and or other tools that can automate the data engineering and operations process. So as I said in the beginning, that basic Python and SQL skills are required to build, run, and manage data pipelines with VDK. And as far as I know, and also from my personal, let's say, DevOps experience, we learn every day as DevOps, and we do something, we use new tools, new languages every day. So any person with understanding and kind of capability of learning, I believe, could be able to create a simple pipeline to start with, but also, to create more difficult pipelines also as well with time, just by following documentation. So actually not just creating a pipeline, but also setting up infrastructure, following the documentation. And this could be just one of the many solutions to implement DataOps and data mesh in real life. But this is one that I see that is or creates this possibility. And the second thing that I wanted to kind of highlight, or that came to my mind as possible issue, is trust. Basically, in my opinion, it's important. The trust is important because domains will now have full ownership over their data and infrastructure. So when it's possibly more reliable to have the infrastructure set up separately from the domain and simply give access to the data. Some companies or some leads or some management might not have enough trust to allow their domain owners to own the infrastructure as well, because of the risks that come with the full power over it, like accidental deletion and any type of kind of errors, human errors also. But I believe that this can be solved by implementing some rules and functionality too. But still, this question remains kind of unanswered to me. And I'm curious to see how DataOps and data mesh will evolve in the future. So with these questions, it kind of sums up from my side on the DataOps and data mesh. And to close this talk, I wanted to thank you and say that I'm really open to hearing some feedback. You can find me as with my name, Agita Jaunzeme, on LinkedIn, any social media. I'm also on Twitter. Connect with me, and I'm really happy to kind of explore these concepts even more and actually find out if they work for some people. And now I want to just dedicate a little moment to speak about the open source projects. And I believe that open source projects are like Versatile Data Kit and actually others are creating or kind of enabling us to not to pay like a lot of money for some functionality. So we actually get some free tools that we can use. And I believe that also they deserve the visibility that is crucial for open source tools or projects to get more known and used, and also to gain potential contributors. And what I want to say is that like actually there is a little support or a little contribution, like giving a star can go a long way. And I suggest or invite you, and I will be really grateful if you support me, my team, and actually what we do at the moment by creating this tool, by giving us a star. So you can just scan the QR code or just Google Versatile Data Kit, and on the top right corner there is a little star. And if you would just spend a minute or so just doing this, it could support me greatly and enable some people to reach and to find the project, to use it and to contribute, or at least to try it out. So yeah, actually that concludes my talk. I wanted to say thank you so much for taking time to be with me. I deeply appreciate having the opportunity to be on Conf42. And also I want to thank the organizers that are, I think this conference is organized very professionally, and I feel so far really positive about how it is managed. So as I said, I welcome feedback. Connect with me, and my name is Agita, and thank you so much, and see you next time. Bye.